So it formats the disk and then rsyncs the files from one disk to the other. So depending on the amount of content you have, it'll take a different amount of time.
Okay. So as long as you hold the SD button during power up, you're fine. Like there's no amount of time I have to hold it after it's turned on. It's as long as I press that power's on from set.
Or maybe hold it a couple
Yes,
seconds.
you can release, no. Well, you if you want to hold it a couple seconds, it's fine, but essentially after the point where power is applied, within milliseconds you can release the button.
We had superstitions running around the department. You hold it until you saw the red one turn to blue, and you had to watch the sweeping go up and down, and then
Get a jumper wire.
I figured out why we didn't get it to work. We don't have that button on here. It's supposed to be down here, right?
Yep. You have a word without that button?
Yeah.
Wow, you've got an old board. Oh, no, it's broken off.
Oh, really?
Yeah, you can just short that if you want. Did it flash? Did it program anyway?
No. It wasn't getting
Well,
into
but
the...
how did it turn off? Oh, okay. Yeah, just
don't stress.
just short it. Just grab a wire and then short the wire there, and then when you plug it in, you can swap the Beagle if you wanted, but I think it's gonna be a lot quicker just to run a jumper wire. Do you need a jumper wire?
Jonas, you're walking around without jumper wires?
I have everything in the other lab.
Oh.
We've got parts as well.
Just took him out of my jumper wires.
Yeah, I have some.
Well, I think he's.
What
are you gonna do?
Wait for it to do like 20 minutes, like during the lab.
You have to do
Maybe that's
something.
what
You can either decide to wait, you can ask a question.
Just thought the TSA might be bothered by it. I don't know.
So we got a wire, or do I need to get one?
I got him a wire.
Thank you.
We'll come back to this diagram again to talk about some other boot stuff, but I want to make sure that we're getting to these questions properly. So that the GitHub fact item, what was that? What was that based on? It was, so how do we verify?
So I wanted to, at this workshop, say, okay, we all understand how to boot properly. Now, if we go back to the FAQ on your page, then does that provide us with a clear enough understanding that for the students that aren't attending the workshop?
So there's one of the newer features of of newer bootloaders is this idea of overlays, right? So we used to handle those in the kernel, but in this diagram here, we'll show that we have these things called a device tree. That is a description of the hardware that we pass to the Linux kernel. So with ARM subsystem devices, so any ARM device now in the main Linux kernel, in order to describe the processor and all the peripherals that sit around it, you use this thing called a device tree. And so it says what your processor is, what I2C buses you have, what memory you have, is essentially all the description. Rather than being described programmatically, it's described with the data structure. And so there's tools to create this little file. And the fun update to the bootloader is that now we can handle changing that description using these things called overlays in the bootloader. So newer versions of our bootloader include this support for overlays. If you're running the really old version of our bootloader, which is U-Boot, right? We're using the open source U-Boot project for that bootloader. Then it won't support overlays, and some of the things that we we took things out of the space.ice tree and put them into overlays, and so those interfaces just won't come up working. Does that?
That's getting pretty complicated. So if there was the
If you ran the
core
wrong
information that we
bootloader-
need, what do we need to take away?
Well, device tree is something you want to understand in general to some degree. So if you want to find out more about device tree, it's you don't need to understand it in tremendous detail, but at least to the level that I described as this is how the hardware is described to the Linux kernel. So what I2C devices are, what I2C controllers I have, what memory I have. Any of the hardware that's hooked up to it, device tree is the way to explain that. Now, there are some exceptions to that, like a USB device. So what has to be explained in device tree is I have a USB host controller, but there are things that are what's called self-discoverable or probable buses. So a USB is one of those. If you connect a USB device, it's self-describing. That doesn't mean it gives you everything down to the register level, but it tells you, oh, I'm a camera. Oh, I follow this standard for how you talk to a camera. So as long as you know how to talk to that standard, you know how to talk to me. For I2C and SPI and all the little things that you're going to wire up to the boards, I mean, those don't have that. They don't have a way to describe what you're connecting up to it. I have a better presentation somewhere that actually talks about that probable bus problem. Anyway, device tree was this way to kind of put that into a data structure, and the overlays allow us ways to augment or extend that base set of stuff. And then if you want to look at the way to configure other hardware, you need to look at the Linux kernel documentation and the examples on device tree. Should be clickable links. Go to page. And this is essentially what it looks like. You have an object and a description. This compatible says what driver I'm going to load, and then there's essentially different parameters that you might set up. There is a I think it's called devicetree.org now. Yes. So this website will probably be pretty helpful. So let me put this in the notes.
So how do we verify that we have an updated bootloader?
So let's log into the board. So as everybody, so if if it's programmed, the thing to do now is remove the micro SD card, remove power, then reapply power, and the board should now boot.
All the lights go off when it's programmed?
All the lights go off when it's programmed.
Ours is still blinking because we started.
Are you still siloning?
Now it's siloning.
Okay.
This guy was.
Edumim didn't work.
And for some, now it turned off. Okay. There's also some header randomly soldered on here.
Yeah, I was grabbing power off to wire something
I
up
did
at
an
one point.
experiment with this, but we never had.
You never had siloning. Did you try it again with the SD card, the SD button held this time?
Just now, just checked off. I don't know what that means. It booted itself,
No,
but that's asking this guy to play with how
Probably not. The way to debug it is, of course, to hook up a serial port to there's a serial header on there, UART0, and it will spit out messages. That's the way to fully debug it, to find out if there's a hardware problem or something else like that that's going on. Can I watch just to see what you're physically doing? Is the SD card properly inserted? Is the SD button held?
Yes.
Only?
And then cable, now you can release the SD button at that point.
And then it just stays like that.
We got
This guy almost.
green and red on, we got the one MIMO on, and the power button. Power LED.
Okay. Yeah, that is indeed a boot failure. There's probably an interface, either the SD card is bad, or there's a problem with the SD card cage on that board or something that's causing it not to read the.
Because we use his SD first on here.
You're saying the
that way,
contacts
that
could
way.
be failed on, when you say the cage, you mean?
The connector to the SD card. We could find out from the boot messages on a UART, so we'll debug that one in a bit. If you could go ahead and pull the SD card just to make sure that the onboard flash does or does not boot. You can pull power first.
Oh. I already.
Either way. And then let's go ahead and boot that one without the button pressed and see if it boots. So it could be the issue is only with the SD card interface. What we could do is after it boots up, we could try to see if we can read the SD card and try to figure out, debug the SD card interface that way. But if the SD card itself is programmed properly and it does not boot off of it, then there's a problem with the SD card interface on that board. That's interesting. You have, okay, this is a, I did forget to mention, because I forgot about it. These particular flasher images have a one extra little step where it defines a first boot up. It goes and defines the MAC addresses for the board and rewrites the initial RAM file system to define the MAC address for the Wi-Fi hotspot. I completely forgot about that. That won't necessarily be the case in images that you create, but these images, the first time they boot up, you're going to see this little two LEDs kind of toggling back and forth after you've booted it up, and then it's going to they'll eventually stop, and you essentially want to restart it at that point. What's going on here is that it's reading the MAC address off of the, and I thought we'd kind of fix this, but it's reading the MAC address off of the chips and writing it into the image so that at boot up next time, the SSID will be unique. And the MAC addresses will be unique. So is everybody
We shift right now on that one.
We took the SD card, took power off, and applied power back on.
and it's there, up and going good?
I think so,
Okay.
yeah.
There's now when you want a development connection.
Oh, we took the SD card. It's doing the MAC address.
There's unfortunately my slides are out of order. Oh, wrong slide presentation, that's why. There's essentially a couple different ways to connect to it for doing development. For the most part, I think that the way you want to do it most frequently is over Wi-Fi. Personally, I like to have a Chromebook laying around because that I'm not trying to do work on, I'm not trying to be on the internet, it's just acting as an interface up to the board. I don't know if that's the sort of thing you have access to, but otherwise you have to kind of switch your Wi-Fi networks until you get the board on the same Wi-Fi network that you're working from. You can also use the USB cable to provide a network connection. There's a little bit of a dependency there with some Windows machines. The driver, like you may be locked out of adding the driver. The driver's already built into the operating system, which is obnoxious, but you still might be locked out from adding the driver. I've seen with some recent enterprise installations. Anyway, Wi-Fi is like tried and true, right, in terms of getting a connection, right? There's no driver installation required on your host machine. every computer knows how to talk Wi-Fi.
Are MAC addresses written in the software, or are they in the hardware and the software just grabs them?
They're in the hardware, so there's in the SoC there are fuses, laser blown in production that are unique addresses. So those are read at one point and put into a firmware file. So the Wi-Fi chip, it pulls its MAC addresses out of a firmware file. I thought that we had it worked around because the Wi-Fi chip itself also has a MAC address.